Welcome back. We're continuing our discussion on solution chemistry. More specifically, we're talking about colligative properties again today. If you recall, we've already talked about two colligative properties: vapor pressure lowering, and related to that is boiling point elevation. Now, it's important to distinguish this. Vapor pressure and boiling point are not colligative properties. Vapor pressure lowering and boiling point elevation are the colligative properties. There are two others I'd like to talk about. The next will be freezing point depression and then something called osmotic pressure. So let's talk about freezing point depression first. Why do we place salt on our roads after a snowstorm? Why do we do that? Well, a lot of folks will say, well, Mr. Hummer, that's because it will melt the ice. And in reality, I don't like that terminology. I prefer this. It lowers the freezing point of water. That's better. For instance, the normal freezing point, we'll call it FP of water, is 0 degrees Celsius. So when it reaches 0 degrees Celsius, if there's moisture on the ground, it will begin to freeze. And of course, it's more difficult to drive on icy roads than it is on wet roads. I think you would all agree. However, if I add salt to the water, the freezing point may go down to negative 10 degrees Celsius. So it may drop 10 degrees. So what will happen to that water at negative 5 degrees Celsius? Well, if I've just lowered the freezing point to negative 10, at negative 5, won't it still be a liquid and easier to drive on? Absolutely. So by lowering the freezing point, we keep water in its liquid phase at lower temperatures, and it becomes easier to drive on roads. You might add ice melt to your sidewalks or maybe your porch. Now this can actually lower the freezing point maybe to negative 20 degrees Celsius. So let's say we're at negative 12 degrees Celsius. What phase would water be in? Yeah, it hasn't reached the new freezing point, so it'd be a liquid, and once again, easier to walk on. Now, the difference between the two, salt, is sodium chloride. When sodium chloride dissolves in water, you form sodium ions and chloride ions. Don't you agree you'd make 2 moles of ions per mole of sodium chloride? Ice melt, however, is a mixture of calcium chloride and also some magnesium chloride. I wonder why they use calcium chloride and magnesium chloride. Well, when calcium chloride dissolves in water, don't you form a calcium ion and 2 chloride ions? When magnesium chloride dissolves in water, don't you form a magnesium ion and 2 chloride ions? In both cases, don't you make 3 moles of ions per mole of compound? Well, why do I bring that up? Well, if you remember, colligative properties depend upon the number of particles, not the type. So wouldn't calcium chloride and magnesium chloride be more effective because they create a higher number of particles per mole of solute dissolved in my water? So they're more effective at lowering the freezing point. And yes, they would also be more effective at elevating the boiling point. And yes, they would be more effective at lowering the vapor pressure. Remember, colligative properties depend upon the number of particles, not the type of particles. It turns out that as the temperature of my liquid water begins to decrease, the kinetic energy lowers and the intermolecular forces begin to take over, and water can hydrogen bond and form a crystal at 0 degrees Celsius. But if we have these ions that are surrounded by water, it makes it more difficult for the water molecules to form those nice pretty hydrogen bonds and make that nice pretty crystal. So it has to cool down even more for that crystal to form. That's why we call it freezing point depression. Does that make sense? You may have also noticed this. I've seen this before. Why is de-icing agent applied to airplane wings in the wintertime? Yeah, once again, because it lowers the freezing point of any moisture that might end up landing on those airplane wings. And there are a lot of moving parts on airplane wings, and if they're frozen in place, it makes it difficult for the airplane to operate properly. So they add a de-icing agent which lowers the freezing point. Here, think about this. Why do we add antifreeze to our car's cooling system? Now, there's the obvious answer, right? There are two answers, by the way, not just one. Why do we add antifreeze? The obvious one is to prevent the engine coolant from freezing, of course. That's why we call it antifreeze, right? That's the obvious one because we call it antifreeze. Of course, how does it prevent engine coolant from freezing? Well, because it lowers the freezing point. So we add something called ethylene glycol. Ethylene glycol, once again, interferes with those hydrogen bonds being formed to make that nice, pretty crystalline structure. So water could freeze all the way down to negative 40 degrees Celsius. So at negative 20 degrees Celsius, water is still a liquid in your car's engine. Remember, as water freezes, it expands. So if we didn't add antifreeze to our car's engine, not only could we not circulate the water very well, but as it expands, could it actually cause damage to your engine block as it expands? So we add antifreeze to prevent the engine coolant from freezing. But what's the other reason that we add antifreeze? Yeah, think about it. Don't we prevent the engine coolant from not freezing, but boiling? Because it elevates the boiling point. So by adding antifreeze, we lower the freezing point, so it might freeze at negative 40 degrees Celsius instead of 0, and it elevates the boiling point. So it might boil at 105 degrees Celsius instead of 100. So doesn't it keep water in its liquid phase? It keeps water, or your engine coolant, we should say, in the liquid phase at lower temps. I shouldn't just say lower, at lower and higher temperatures. Okay, so we have 3 colligative properties that we talked about so far: vapor pressure lowering, boiling point elevation, and then finally freezing point depression. There's one more, osmotic pressure, and we'll get to that another time. That's it for now. See you soon, kiddos.